Okay. See. Who is Annie Manosea at Gmail?
Yes, I'm here.
Hello.
Yes, sir, I'm here.
Are you there?
Yes, sir.
I've dropped it on your email box.
Okay, I'll check it.
Please help me disseminate it while we still try to connect. I don't know what's going wrong. As soon as you do that, let me know, please. So, having done that, hello? Huh?
SSD transfer from January 19th. If you use your app,
Hello?
you use your phone, they say that transfer charges, where bank they collect, don't make up too high for this.
Hello?
Yes, hello. We can hear you, sir. We can hear you.
You can hear me? Okay. So have you disseminated it?
Yes, sir. I've shared it on the WhatsApp group.
Okay. So I assume everybody has it now. Hello?
Yes, sir, we have it.
Yes, sir.
Yes,
It's
we
in
can
the
hear
group.
you. We are downloading it, sir.
Okay.
Yes, we are downloading it
Okay. So I can continue.
on our WhatsApp platform. Yes.
Okay, so are we all there?
Yes.
Not yet, sir.
Okay. This course has to do with measurement tools and technologies for particularly sampling strategies in environmental monitoring. This is part of an integrated, innovative approach for precision and compliance as we are looking at the slides, you'll find out that here in this course, we will try to integrate real-time data, of course, sample collection, collation, real-time data acquisition, the processing, and its application to environmental monitoring. One would see that our today's environment is different and has metamorphosed into something that requires a continuous, updated monitoring system and approach, as the case may be. And the environment involves both anthropogenic and other activities that affect both the air, the water, the land, and even underground, as the case may be. To an extent, too, the environment goes beyond the atmosphere. When you look at impact of space exploration on the Earth here, you will discover that some of the things that we require for space exploration directly or indirectly impacts on our immediate environment. For example, you have the materials you mine to produce the space shuttles and space equipment, gadgets, and all that you require in space. These also impact the environment directly or not. Please, can we all mute our mics? Can we mute our mics, please? Can we please mute our mics? Okay. Looking you very much. Now, looking at what you will discover that today's environmental monitoring. You know, I'm thinking somebody's mic is unmuted. Please, can we mute it? Okay, thank you. Today's environment requires. Tefa, please, can you mute your mic, Tefa? All right. So today's environment requires the use of gadgets and equipment that are very important and real-time online probings. For this course, we will have some learning objective that we are going to abide by. And it's expected that at the end of this course, that candidates will be able to define the principles of environmental monitoring and its role in public health, ecosystem protection, and regulatory compliance. This way, you'll be able to at least define a border within which environmental monitoring is engaged. The other one is that at the end of this, we should be able to compare traditional, that is lab-based approaches, and the emerging technologies like the sensor and Internet of Things measurement approaches for this environment, such as air, water, soil, and biodiversity. We should be able to also design statistically robust sampling strategies for diverse environmental media. The other one is that we target being able to evaluate the impact of regulatory frameworks from bodies like the FDA, EMA, COP29 on EM practices. And we should be able to predict future trends in environmental monitoring, including automation, AI, and climate-driven innovations. I feel that with this, we should be able to have such outcomes like students being able to demonstrate competence in selecting tools or sampling designs for complex contamination scenarios, such as where you have PFAS in water, methane leaks, CO2 contaminations, and the rest of it. We should be able to have, as one of the outcomes, students critically analyzing environmental monitoring data, data variability, and recovery efficiencies with the challenges that come with them. We also believe that at the end of this period, there should be the capacity to propose an integrated monitoring solution where we can involve ground satellite AI for urban and industrial zones. We should also have within our kitty ability to advocate for sustainable environmental monitoring practices, which should align with COP29 and EU Green Deal goals. This way, we'll be very sure that we have done justice to this course. If you follow me to the 5th slide, are you with me?
Yes, sir.
Okay. Now, the essence of this activity hinges on certain key drivers. Why do we have to monitor? Why is it necessary? Why is it important? Well, one of the things, the key drivers is that in monitoring, we try to ensure that there is regulatory compliance because we've already had these bodies set up frameworks, policy frameworks, guidance within which certain things are supposed to be carried out within our environment, in our ecosystem, in order to maintain a safe ecosystem. But if we do not monitor what goes on or what people do after a while, you will discover that there is this tendency for humans to deviate from set rules. There are ground rules that needs to be obeyed and ensured that they are always there. So we monitor to regulate compliance. We monitor to ensure that public health options are made available, both with the air quality, water toxin detection, even the groundwater, state of groundwater, and what we have, particularly in areas where agriculture is practiced. There are certain industrializations that comes with backlogs of accumulated toxins. For example, looking at a place like Niger Delta, where oil exploration is at its peak, there are definite public health challenges that occur from such things. Some of the waters are polluted. People drink polluted water. The fish is also polluted. And this fish serves as food and economic means for riverine people. So it's also good to monitor in order to ensure the ecosystem integrity is maintained, that we don't lose things like biodiversity, that we don't have habitat degradation, that we don't have huge unacceptable eutrophication practices. One problem that occurred very close to us here in Benue State is the cassava processing factory that was putting in a lot of unwanted materials in our environment, particularly the water body. So without monitoring, these things will not be monitored, and a lot of things come into play. We have for example, from the cassava plant, we have a cyanide eutrophication. You also have things like heavy metals or metalloid that are put into the environment. You also have mineral oils that are found within this environment. You, some extent, have polycyclic aromatic hydrocarbons, that's the PAHs, and the PFAS, as we have initially mentioned. So it becomes very important to monitor and consequently control some of the resources that may be scarce. So we provide resource security to them. Water is one of them. Despite the fact that we have a lot of water, abundant water sources, if we don't guard them, these water bodies that serves us for different purposes will definitely get polluted, contaminated, and they'll become useless to man and create an artificial scarcity. So it is very important that we monitor. And I think it serves us great purpose to have such environmental policies and practices in place. There are certain parameters that we require to monitor, and these parameters are the ones that adversely affect the environment, be it air, be it water, be it soil, and be it even beyond that atmospheric region. And some of them are the ones like air. In air, we have the particulate matter. We're looking at a PM value of 2.5 over 10. This is the baseline that which threshold should not be exceeded. We also look at the presence of ozone, the O3, and the presence of the SO2 and the nitrous material, the NOx. The volatile organic carbons are also the VOCs, and this all impact the greenhouse effects because they give rise to the existence of the greenhouse gases, which are hazardous to man and his environment. Then for water, we have certain parameters like the pH of the water, the dissolved oxygen of the water, the biological oxygen demand, and the chemical oxygen demand, the turbidity, nutrients, like the nitrogen and phosphorus, the pathogens, microplastics, nanoplastics. These are presence that we need to monitor. These are parameters that we need to check. They have thresholds that impact the environment, particularly the environment where they are found, where they come into contact. Now, for some of them, you discover that they have a cross-border effect. What I mean by cross-border effect is that some, like the nanoplastics, you may find them both in the water body and the air environment, as well as the soil environment. So it's not just because of one particular environment, but they are monitored across different environments, as the case may be. The other parameters that we consider can be specific or particular when it comes to the soil environment. And here we have the organic matter, the degree of the enrichment of organic matter in the soil can be of particular concern. And this can be as a result of certain eutrophication processes. We also have the texture of the soil, as well as the heavy metal presence. Some heavy metals like the arsenic, mercury, the cyanide, the iron, the lead. These are heavy metals that we check for their presence and prevalence in the soil environment. And these are parameters that gives us a very good understanding of the safety status of that environment and its adjoining environments too. We also look at pesticides. Pesticides are also very important parameter that we need to consider. We have residual pesticides that are found in our environment, and we also consider their resident time, half time, that shelf life, impact on organs when ingested, and mode of contamination. These are some of the things that are considered when you are carrying out environmental monitoring. Then we have the PFAS that are one of the recent concerns when it comes to environmental monitoring and forms a very vital parameter for consideration. For the biodiversity space, we have species abundance. This is where you encounter invasive species, invasive plants, invasive animals, invasive entities. Some plants, for example, Lantana camara, when once it's found in an environment, it has a tendency to multiply rapidly and thereby killing the natural or original inhabitants of that environment. There is a displacement culture with Lantana camara species. These are some of the things that need to be monitored. They form the parameters that would guide environmental monitoring as the case may be. Now, the other one is the eDNA and the bioindicators like the lichens and the microinvertebrates. Their presence in the environment is also very important to study and monitor. Having said that, one now understands that environmental monitoring is of great essence and importance. Now, coming to the approach with which we do our monitoring, there are basically two approaches: the traditional approach and the emerging tools. The traditional approach requires the lab-based gold standards, where we use equipment like the GCMS, LCMS, ICP, MS, and these tools give us detections in as small as ppms, that is parts per millions. However, they have the shortcoming of time, real-time analysis of these materials. With the traditional approach, the lab-based gold standards, you discover that you need to carry these samples from their sources back to the lab for analysis. And that time space within which this happens can allow all kinds of contaminations, wrong readings, and the inavailability of real-time online results. So they have these shortcomings, as well as the fact that the equipment that are being used are expensive. They are expensive equipment like the LCMS, MS, ICPMS. These are expensive equipment that not every lab can afford to have. They are also discrete when it comes to sampling. Meanwhile, they have good advantages of high accuracy and they are accepted by regulatory bodies for use in regulatory policies and frameworks. So as the need for very quick, fast analysis becomes very, very necessary, the emerging approaches that requires in situ analysis of these contaminations brings about the revolution where electrochemical sensors, as well as optical sensors, are deployed. These are materials, these are sensors, equipment that, while in the field, they'll give you an idea or generate data based on optical observations or electrochemical reactions and voltage readouts that indicates the level of contamination. In recent times, the use of drones, satellite remote sensing, have also been incorporated in environmental monitoring practices. They have the advantage of giving us real-time, continuous results, whereas they are cost-effective because of handling cost, reagent required, and which is not applicable for the emerging ones, but are applicable when it comes to the traditional methods. So these two gives us the options. In as much as the emerging ones have their advantages, it has not replaced, or they have not replaced, the traditional approaches, because the traditional approaches are still valid and very accurate and can handle bulk samples within a particular period of time. So both are being used at the same time, and they complement each other very well. Now, further looking at this, we discover that when it comes to sensitivity, the ones that are used particularly for traditional approaches happens to be the GCMS and the LCMS, ICPs. And these ones require the use of reagents, the use of equipment that you need to calibrate, you need to standardize, and before you have your results. And they give us results at the PPT level. Whereas for the emerging innovations, we have the nanosensors, which are for in situ heavy metal analysis. These sensors can sense while you are there in the field, and they don't require the use of classical methods of approach where reagents are used and discarded. And of course, discarded reagents also constitute environmental stress because of their presence. They need to be treated, and cost is then involved. The other thing about these two approaches is that for the traditional approaches, speed is a disadvantage. A typical analysis can take up to between 7 and 14 days for the lab results to be out, for us to confirm what we have. Whereas for the emerging innovations, we have real-time Internet of Things telemetry that gives you results within some seconds or minutes. And that's an advantage that it has over all other the traditional method. Now, when it comes to coverage, the traditional approach gives a discrete grab sample. That is, it just what you introduce, the one you introduce as the sampling material, representative sampling material that is sampled. Whereas the emerging technologies are innovations, such as the satellite constellations. They give a wider coverage, non-restrictive coverage, thereby giving you access to more information over a wider range of environmental space. And for cost, it's been proven that the traditional method, like I've said before, involves higher costs than the emerging innovative approaches. So it becomes very important to adopt the emerging approaches while not completely discarding the traditional approaches. Now, we will notice also that these emerging approaches have the tendencies also to be more specific in their approach. For example, when you are dealing with a satellite remote sensing, one will discover that the remote sensing has a lot to do with what is programmed into it. For example, a sensor like the LiDAR is usually applied for vertical profiling, while the MODIS or Sentinel for resource are applied for other non-discrete but non-specific environment, as the case may be. Now, the typical example is the case of that's New Delhi's air quality network, which integrated about 50 plus IoT sensors. So it finds data from the environment without a closed border or restrictive space, which is an advantage for us, as the case may be. Now, having said that, I don't know if there are questions for me to take before I continue. Are there questions for us to?
And I think, sir, I suggest we ask question at the end of the day.
Okay, because if some people maybe in between, they may get lost or something, but no problem, we'll continue.
Okay, sir, thank you.
All right, you're welcome. But I hope
Please,
you are following me. Sorry?
Mine is not a question, it's a suggestion, sir.
Okay, go ahead.
Please, there are a lot of persons that wish to
Nanev.
join the group. Yes, this is
Sorry?
Nanev talking. There are a lot of
Okay.
persons that wish to join, but they cannot because of the capacity. Can you increase it? Is there a way you can increase it now? The capacity is 100.
Capacity of what, please?
Of the Zoom meeting we are having right now.
Okay, the
You are
class
host.
capacity
Is 100.
is
Can you
100.
extend it to maybe 300?
Okay,
Yes, maybe you can extend it so that others can join.
Okay, I think that one will be from the technical team, the Apex technical team. We already hit 100, I can see that, yes. How many do we have?
We have over 300 students, and there are a lot of persons complaining on the WhatsApp group that they cannot join. From what I heard, I think we have up to 300 students, if I'm not mistaken. So the group can be extended to at least 350, 400 thereabout. That's it, to accommodate everybody.
Okay, that's true.
No, yung ba nila namin sa mga
Hello?
We can hear you, sir.
All right.
I hear you.
Okay. So having said that, the places where we easily deploy the emerging technologies are also like I mentioned before, the satellite remote sensing, urban innovations, where in cities we project to monitor certain things, maybe like gas leaks, water leaks, and some areas where you have a lot of demolition, for example, demolition activities, particulate matter that is, spewed into the environment. So in such cases, we find out that we can have real-time emissions mapped using these emerging technologies, such as the ICOS cities project, where the emissions were mapped and we could see the hotspots, so to say. In this environment, you will, with the vision, with the sites where you see the hotspots, you discover that you can easily manage to divert the flow of traffic or human activities away from the hotspots, thereby safeguarding both the environment and the people. A typical example for us here, those of us in Makurdi, is a place we know as Wurukum right now, where there is a construction activity going on. You see, because if we use the mapping, we'll be able to know the hotspots, and with that, we can effectively deploy remediation systems like the conventional watering of the environment. That can serve as our quick remediation approach. So something like the ICOS cities project gives us an idea, and the New Delhi's air quality network can also come to mind easily. A typical example is looking at that. You can see the map I have there. That is the 10th slide. You can see the satellite image showing an algae bloom in a lake, Lake Erie. You see, in as much as this is just for the study of the presence of algae and how it is spreading, you'll be able to see and understand the area that are affected and easily plan a containment strategy. Here we look at some use of a multi-parameter sondes, such as the pH, DO, or turbidity, or conductivity. These are the things that information are the things that we gather from certain GIS and the remote sensing applications where mapping is done. With the mapping, we can contain them because you will know the area, the landmass, the distances that you need to cover, and of course, the amount and the quantity of the remediation items or material or activity that would be required and then deployed. And so also with remote sensing, we We use equipment like the hyperspectral imaging. That's the approach for particularly chlorophyll A that is suspended in sediments. And this gives us materials that are between 700 and 800 nanometer in sizes. And of course, the traditional lab approach will not be able to do this. That is why the emerging technologies where AI, IoTs, and all that are involved come into very successful application use. Now, for certain emerging contaminants, the detection of PFAS that is detected using LCMS, MS, then you have the microplastics, nanoplastics. We use FTIR spectroscopy. But in this case, we are still looking at the possibility of using some emerging or developing technologies where sensors that are sensitive to these things can be deployed in such environments so as to have real-time online data collection and activation of the remediation processes. These are still emerging technologies that are futuristic, but the fact still remains that they can be detected. They can be also this containment plan put in place. For other areas, such as the soil and biodiversity monitoring, we can use equipment like the portable XRF that can detect the heavy metals contained in soil without necessarily, taking soil samples from sites to the lab. We can use the portable XRF, for example, for heavy metals. We can use the ERMI spectroscopy for organic carbons. So some of these equipment and gadgets come handy when we are looking at environmental monitoring. Now, for biodiversity, as the case is, we thank you for sharing this. We have the eDNA sequencing for species detection. We also deploy drone-based thermal imaging for wildlife tracking. There are some parks, national parks, where each animal is tagged as in TAG, tagged, and they can use their satellites with a drone support to track the movement of every animal within that range, that park. So these are ways of monitoring the environment, monitoring the animals, monitoring, in biodiversity. And of course, the DNA sequencing for species detection is also very possible by taking samples of these species, as the case may be. One typical case we are citing here is that of Chile's soil remediation, where waste-derived amendments were deployed. Though in this case, we find out that the soil that was being remediated was tested, and then the waste that was gotten from another, because most times you find that soil organic matter, nutrients are depleted. Then this will cause a lot of problems when it comes to leaching of water, drought, and availability of nutrients. So when this is monitored and found to be a challenge, like in this Chile soil problem, the waste that was derived from amendments were introduced to re-enrich or fertilize the soil. And it is monitored. The capacity of the soil being remediated to take as much as is possible is also monitored so that you don't have an excess of introduction of these organic nutrients. So these are some of the examples of monitoring that takes place in some of these places and why we need to do that. Now, like I mentioned earlier on, the satellite based monitoring goes beyond the atmosphere, but it helps us to some of the examples are the Landsat and Sentinel, the GOEs and the radar sats. It helps us to do what? Look at the GHGs. The GHGs are the greenhouse gases. We track them, we monitor their volumes and their levels. We also monitor how fast they are generated. And as such, we can trace back to the sources of this generation and try to remediate or stop them completely. The satellite imaging too, the satellite-based monitoring, also helps in the monitoring of ozone and its depletion. Ozone gas, which helps in protections such as the UV radiation protection and the rest of it, helps us to know where our anthropogenic activities affects or is affecting the ozone layer and ozone content of our environment. Then also for land, we use satellite-based monitoring to monitor deforestation. Deforestation can be as a result of wildfires. Deforestation can be as a result of intentional falling of trees. Deforestation can be as a result of animals being integrated into a system that is not supposed to house them. This can cause the degradation and the deforestation. Then we use this satellite-based monitoring to monitor the rate at which deforestation occurs. Now, for urban heat islands, there are certain so-called heat sinks that are made available or made they're meant to come into existence within the urban setting. And this may be as a result of industrial processes where you have a lot of industrial activities, like where the cement industry is working. Hello?
Yes.
Hello? Okay. Any
Yes.
We can
challenge?
hear you. We can hear you.
Okay. Where the activities, industrial activities of these industries generate materials that affect the environment, particularly temperature of that environment. When there is the spewing of hot materials from their chimneys, from their boilers, you discover that it also shifts the balance of the environmental temperature. So one can use the satellite-based monitoring facilities to mark out the hotspots, the heat basins, and note why they are happening. Even once they are traced to a particular source, then it is easy to remediate. It is easy to prevent. For example, if such sinks, the heat sinks, they are coming from boiler systems, there may be a way of heat recovery from those systems. It can be another additional attachment that will channel the heat being generated from the boiler systems to a harvester system where they are condensed and probably turned into water and used or circulated for other purposes. That will, in a very good measure, reduce the level of heating of the environment as a result of this process. So the satellite imaging can give us that leverage too. That is when it comes to land. What about water? Like we saw before, the algae bloom, they are very possible monitoring approaches by satellite imaging, the satellite capture, the GIS monitors, and other ones like the oil spills can also be part of this problem. When you have oil spills, remember that it's not everybody. Some of the spills occur on water bodies, and you may not have direct access by walking into the water body. But with satellite imaging, you discover that you are able to capture the affected land area or mass as it is and plan effectively your containment approach. If a whole land mass of, say, 1 knot is covered with oil, you'll be able to plan how many of the what is called booms that you can deploy to cage or contain the water, the oil from spilling and spreading further into the water body. But if you don't have these satellite images, you will discover that it will be difficult for you to estimate the number of booms you will need to be able to contain the continuous spread of the oil. That is where this satellite-based monitoring becomes very important and is essential. However, they all have their limitations. Each of these have their limitations. And one of which comes to mind readily is the atmospheric interferences. For example, when you are trying to carry out a satellite image and there is so much dust in the environment, definitely that may cause a haze and an opaque picture being captured. It may even be that the environment where you are capturing, for example, in the up north, the core north area, and you are trying to capture the invasive spread of a particular plant or anything under biodiversity, and there is a dust storm, definitely the satellite image will not be very clear because the camera lens would be covered with the dust storm. This is just a typical, very simple explanation of how atmospheric interference can, be a problem when it comes to satellite-based monitoring. The other one is, for instance, if you have a situation where there is fog in the atmosphere, there is fog, and you are taking or carrying out monitoring, early morning monitoring, like in a place like the Niger Delta region, we are trying to look at the extent to which the oil has spread. Definitely so, the fog will not be able, or the smog will not be able to allow the image to be well captured. They may be appearing fuzzy and unclear. So that way it affects it. Other ways the atmospheric interference affects it is the presence of reactive items within the environment. For instance, if the satellite-based monitoring has anything to do with the use of chemicals or reagents, some of the gases found within the atmosphere may be reactive to those reagents. For example, where you have an ozone an environment and you are looking at an ozone depletion and all that, the reaction between ozone and any of the reagent that you're using for your sensing, there may be a problem. So this way you discover that the atmospheric interference plays a role in limiting or the limitations experienced with the satellite-based monitoring. The other one that also happens is the resolution trade-offs, where the equipment being used has certain or requires certain level of resolution to give you peak values, and they are not carried out well due to certain shortcomings. It becomes a challenge to the process. So one would ask, how do this work? Let's look at the sensor networks and the telemetry. The sensor networks and telemetry individually has certain components. Of course, you have the sensors, which is part of the components, and they use the LoRaWAN and cellular cloud dashboards. These are components built into the sensor that they, when deployed, thank you, Angua. When deployed, they gather information into the database, and this information is usually analyzed, and feedbacks obtained from them and sent back to the control room, where they are interpreted and used. And what do they use them for? Some of them are for early warnings, like when you have flooding, when you have spills, when you have earthquakes, when you have landslides. Some of these things, when the sensor networks and telemetry are deployed, they give us a projected information for mitigation approaches. That is why some bodies, regulatory bodies, would, like NIMASA and the rest of them, will give you early warning signs and signals and notifications that so thing will happen so time. For example, oftentimes before there is flooding as a result of increase in flow of water along the River Benue, the public are informed, communicated for them to do what is called pre-disaster remediations. These pre-disaster remediations are things you do before they occur. Because, for example, if you have a house built around a place that is prone to such disasters, you will not be able to, excavate the house and take it to another place. But you'll be able, with early warning signals, you'll be able to build strong barricades around the building that would sort of shield, forestall, or minimize to a great extent the impact of that particular natural disaster. So some of these things are the benefits. Also, in a way, they also reduce the costs of aftermath of certain disasters. And you understand that it will also inform us of what to do and what not to do, because this comes with precautionary advice, and one will take it and stay safe, while when you ignore, you bear the consequences. A typical example, like as I have on my slide here, is the watershed buoys that are tracking nitrate pulses in real time. These materials, these buoys attract the nitrate composition of a water body, because the essence is that the nitrate level is synonymous to the amount of algae that you are going to get within that water body. Algae requires certain food substances to survive. And when one particular food substance is high or low, then the possibility of that algae to survive becomes predictable. So this way, You either increase the nitrate content or reduce the nitrate content, as the case may be. So these are some of the advantages of such things. And sorry, before I go to the last slide, it's just a question of, from the slide that you can see from the, environment where that is being monitored to a receiver sensor station that is like a mast, which broadcasts or boosts the information to a control station, a network where the readouts are done, and you now have a readout, and a decision or decision-making process takes place. So you have the sensors, you have the cellular materials or the LoRa one, and you have the cloud space where it is done, stored, and transmitted back to a dashboard, an office dashboard, of course, which tries to bring us simulations that read out to the human being. And then thing to consider in environmental monitoring here is the statistical sampling fundamentals. Because we are looking at not one, not two, but a population, we look at them and we can define them as either spatial or temporal boundaries. Populations can be defined as spatial or temporal boundaries, such as what we have with the soil in the watershed second quarter 2025. Now, the key strategies for this statistical sampling happens to be caught up in 4 major classes or categories. One, you have the random, which is the unbiased, but has the possibility of missing out on the hotspots that is required or maybe of importance to us or the readers. Then you have the stratified. The stratified based on the grid system for spatial correlation and analysis, where you divide the environment into strata and take your sampling from that point. You also have the systematic type. Here, it is the grid-based, but for the spatial correlation analysis. You tend to look at 2 different environments, 2 different spots, and balance the analogy of maybe one is this or the other one is that. You make sure that your area is correctly or systematically divided or demarcated, and you take from each of those spots. Now, the other one is the cluster type. The cluster type is where you have them together within particular regions as may be chosen. And it is found that the cluster type is efficient for patchy distribution. For instance, where you have materials like the lichen and the boulders. These are environments where the materials are always together. So they form their clusters. And there is need also to ensure that each cluster is well represented and captured, as the case may be. So it's not it's not a very, very unique method, because outside those clusters there may be it may be little, but it's still part of the impact from the outside. But most of them are caught in the regions of the cluster, as the case may be. Now, having said that, I want us to look at the temporal sampling designs. Temporal sampling designs. These are the real-time sensors, and they are deployed in areas such as the urban air networks. These real-time sensors are meant to give, like mentioned before, the real-time impact or effect of the environment that is being contaminated or challenged. And it works on the premise that there is a before and after control impact, which is known as the back. So for an event or disaster assessment, the before, the after, and the control they are all looked into to assess the degree of impact of a particular thing. And the adaptation that is carried out here is that the frequency is adjusted based on the risk. The frequency of the backing is adjusted based on the risk. And these some of these risks, like the monsoon-driven water sampling, where because of the monsoon that the sampling is not collected effectively, or that the materials are not well distributed or reached out to. So it becomes a challenge for this to happen. Then the challenge also is that depending on the type of contaminant you are dealing with, you find out that you have the before, you may not have the before, but you may have the after. For instance, let's go back to water around the Niger Delta area. Before exploration, they may not have carried out any analysis to ascertain what is known as the standard. Now, the problem occurred and we started going around looking for solution. So there may not have been a before, but there is an after. And I believe that in such cases, assumptions are made in order to carry out the monitoring. Assume that, oh, this is a salt water, this is a salty water, this is a river, this is an ocean, and all that. What are the standard parameters found within an ocean? You would see that happening. And afterwards, what is it now that these people have been kind of reluctant to leave? You discover that the oil that has been spilled are so entrenched, the pollution is so entrenched into the system network that it becomes very, very difficult to separate or contain. And what happens? Control becomes a problem. But when you apply control and you are finished, you have to do the after thing. And the after thing is what? The impact. What is the impact? How do we remedy the impact? What and what do we do to make sure it doesn't get to this point again? And that becomes a huge challenge for everybody. Because the impact at the time we are going through the monitoring, we have gone beyond the small scale monitoring that remediation that should have been done into large scale that should have been done. And of course, you discover that it becomes very expensive. So that is why it is always good to have these monitoring exercises done as early as activity starts in an environment and as frequently as possible. Now, for quality assurance and quality control and sampling, one very good benefit is that they have the tendency to incite the recovery efficiency of the system. What happens? For the recovery efficiency, the critical, this QA is critical for surface sampling. For example, when you contact plates and the plates yield up to 53% with roll and 16% with press, then what is called a calibration drift is affected. Now, these plates we are introducing collected as much as 53%, whereas the same plate, when subjected to release of the mopped up oil, was able to yield 16%. Consequently, most of the contaminants were retained. They were retained. Now, the other one is the calibration drift. The calibration drift, if it goes, say, as much as 30% of its deployment status, it becomes a challenge. If the system or the equipment is deployed to give, say, a 70% efficiency and is giving a 30% efficiency, then there's definitely a problem. Of course, the QA and QC ensures that this does not happen. For EU GMP, this requires the recovery efficiency data for environmental monitoring methods. And well, the thing there, the whole idea there is to validate the results that have been done, the result of what was obtained. Just like the picture there depicts the role that mops up contaminants. If you validate it and it is within the same range, then you can be sure that you have done a good monitoring and evaluation and under environmental monitoring. Now coming to the regulatory frameworks. We have different regulatory frameworks, policies, and bodies, all depending on what you are looking at. Some of them are the FDA, EMA. These ones are for risk-based environmental monitoring. They are also concerned with the disinfectant efficacy. And they are all part of the trending analysis. The Global Maintain Pledge. This drives the policy-led emission reductions. It is just for us to know that methane is not the best thing for us. And we should, as much as possible, try to reduce any activity that will generate that. The COP29 has had to do with carbon trading and verification under the Paris Agreement. Nigeria has bought into this and so many other countries. The more forests or wildlife you keep, the better this serves you. And you discover that basically virtually everybody needs to be aware of COP29. Then a case study is that of FDA warning. Yeah, a case study of FDA warning letter to sterile manufacturer for EM failures. We need to carry out some other case studies, even here in our local environment. There ought to be some measure of understanding of what is going on. And I hope we'll be able to do that. These are some of the case studies that I positioned there for us to see. If you look at that environment, the pharma industry, you will see the positions or positioning of their places, workplaces, the sampling points, the input materials, and the rest of it. What did they do? Glass, these are critical focus areas for surface recovery efficiency, contact plate swabs, aseptic processing zones, and all that. These are where monitoring, environmental monitoring becomes very essential and very important. And they do their monitoring using certain equipment like the biomerics. Definitely, you will have, first of all, a place that is clean. You have your clean room, you have other areas, but to work carefully, not to be contaminated and not to contaminate anybody. I will say that. What are the future trends? Our time is almost there, but let's look at this quickly. Future trends: carbon and methane, the carbon capture thing, the methane monitoring, the polymer production, where you have the issue of nano and microplastics, the PFAS, the mitigation and all that, desalination. Though desalination is not a problem in Nigeria per se, but there are places where it's a huge challenge. So there are things that you can do to desalinate the water, make the water drinkable, make the water usable and all that. And then the use of remote sensing in all the hazard-prone environments. So, okay. Now this is continuation of that, where we use the automated sample prep, where AI and that is the artificial intelligence and machine learning are also deployed. The digital twins are there, and yeah, like the slide shows, it's all about connectivity, where you collect your samples, you analyze real-time online, you feed a data control unit that analyzes it and sends information back to a central control point, and decisions are taken. Having said that, what are the challenges ahead? We have a technical challenge where we experience, like I mentioned before, where you have smog and fog covering certain things. We have a sensor biofouling, detection limits for emerging contaminants are also hampered. The data management aspect too, be it human, be it otherwise, it also happens. Validation of AI models, as well as the socio-political interferences, such as the US Paris Agreement withdrawal, and of course, we know what the trending thing with the USA and some other countries like ours. When they withdraw from certain agreements, it becomes a problem. And the high cost of tools is also a problem, because it is also hindering the possibility of a global monitoring activity or possibility. Well, this is my conclusion for now, and that is that there should be integration of imperative. Integration is very imperative, because no single tool is enough to monitor effectively. We need to, marry some of these technologies, both the traditional method and the emerging methods. We bring them together to have a more robust information gathering, analysis, and validation to give us an output that is concise and to the point. And this calls to action the fact that we have to look at automation and uphold statistical rigor and bring up advocacies for policy alignment. And at this point, I would want to pause and ask for one or two questions before our time. We'll just have like 1 more minute, and for us to leave this session. Thank you for your time and your patience. So we can have contributions, questions now.
Thank you, sir.
Okay.
My is just a more insight, or we should throw more insight.
More insight on what? On which area?
Yes, on slide number 10.
Slide number 10. Okay,
Yes.
that is the slide that has to do with this area mapping. That is the RJ monitoring.
Yes. Yes, sir.
Okay. That slide, what is it that you really don't understand? So that I would know. But what, in a nutshell, it's just about the use of the satellite imaging to capture areas that are affected by a particular challenge. That is, in a nutshell, what it does. And what we experience there is the use of satellite images of different technologies. There are different technologies, just like you know what GIS is?
Yes, sir.
Just like you do your GIS, there are components that are like GIS too, that you use to identify specifically populations, areas based on interactions. For example, that of the algae that we're seeing there was possible because of the color reflection that is obtained by focusing or zooming on that area. The algae has a particular unique color emissions. So that color emission indicates on the system, on the equipment, that, okay, this color is showing, this means it is algae. And that color has boundaries where it is showing, and that is where the algae happens to be. You understand? So it shows you that map. That is like mapping it using particular algorithms. You now see, oh, the algae is taking this spot. Every other thing that is not giving that particular color signal is not algae. So, excuse me. So you discover that, oh, the algae is covering this area, but it's not within this area. So you can, using the data and the image you have, you can decide to find out the distance or the perimeter that the algae bloom covers. And that would guide your remediation approach when it comes to material input, strategy, and amount of time required to carry out that remediation or mitigation process. I don't know whether I answered to your concern. Yeah, that's the number 10 there, water monitoring technologies. Hello.
Yes, I said when you mentioned GIS and you went further to say there are technological tools used in mapping, it have cleared me more.
Okay, that's good. That's good. Yeah. So you can monitor that from even the space using those things, color, intensity, heat, vibrations, and all that. That's what they use. They, you know, as you are now, as a human being, there's an amount of heat that you radiate ordinarily. And there are sensors that can pick this heat radiation or emissions from a very long distance. That is how they will know. The heat radiation will show, oh, that is a human being they're going. How many human beings do we have around that place? Just by the heat emissions and radiation that we have. It will not be the same for animals because our metabolic activities differ. It will not be the same for insects. It will also not be the same for trees and shrubs and grasses. So it becomes peculiar and unique. So they use that to say, oh, this is human being, or this is a tree, or that is an insect. And then the mapping can take place. You know where they are. Any other question?
Yes, there is. Good morning.
Okay.
Morning,
good morning. Adoga, how are you?
Fine, sir. Thank you.
Okay, go ahead.
Sir. So I heard your sampling technique with reference to statistical model, cluster, random, systematic.
Yeah.
Okay. I want to quickly ask here regarding satellite-based monitoring.
Satellite-based
monitoring. Satellite-based monitoring.
Okay, satellite-based monitoring. Okay.
Yes, with particular reference to a satellite imagery.
Yes.
In applied context.
Yes, go ahead.
If I want to assess the land use and land cover change of Abuja, I currently base in FC.
Okay, go ahead. Yes.
And I want to deploy Google Earth Engine to assess data from the cloud.
Okay.
What are the suitable sampling techniques that I should deploy as an environmental monitor?
Your target is for your target. What's your target? What's your target? Primary target? Okay,
my primary target is to check the rate of urbanization is on the rapid growth. Estate development is on the increase, and there's massive road construction. So definitely there is a dramatic change in the land use and land cover. Deforestation happening left, right, and center. Temperature is changing at an alarming rate. and I want to
Yes.
track
Okay.
using satellite image.
Sure.
How do I
Now,
have a
okay.
standard, I mean, a fair sampling representation using satellite image? Because it's not statistic model that I can easily employ. I can adopt cluster techniques or random or what. All the statistical models are not applicable here because this is image. I'm going to be using image in this scenario.
Yes, I agree with you. For your concern, let's go to, please, the person sharing the slide for me. Thank you. If you go to slide 12, I want us to look at slide 12. Slide 12 has to do with satellite-based monitoring. I want to point out some things there. Slide 12, my 12th slide. That slide there, you will see that one, first of all, you break down your parameters. What parameters are you going to consider? In all of this, Adoga, you are with me, right?
Yes, I can hear you.
Good. Now, human beings are involved. Movement of human beings are involved. Yeah. Now, movement of disappearance of trees, shrubs, land masses. Okay, trees, shrubs are also involved. So the landscape changes. That is one. Two, where there is industrialization or there are construction activities, there is the possibility of generation of dust. So particulate matter becomes an issue again. Aha. Now,
Okay.
you can decide to use these three parameters as a preliminary study for monitoring this drastic urbanization process. Now, if you are going to do, like we talked about, mass movement of people, you can use your satellite imagery to detect heat waves apart from sun's ray from human beings during the day and at night. Remember that during the day, you have more activities within an industrialized or cosmopolitan area because a lot of people come together to do one activity or the other. At night, this same place experiences less amount of heat, radiation, or emission from human beings because they must have gone away back to their houses. That is one parameter you must consider. Now, the other one is, how do you look at the greenery? What is the initial? Remember where we had initial, now, and after. What do you have before the construction? What do you have now the construction is in place? And what will you have after the construction has taken place? But for the fact that you want to monitor urban migration and its effect, you may not have the after topographical picture of landscapes. You may have and now. Where areas have been cleared for construction, you will not have greenery there again. That particular place that you will capture, if you are, look at that satellite-based monitoring, you will see that there are places that are reddish in color. Those areas are heat areas. Look at the areas that are greenish. The heat areas are no longer around them. So you can use those ones to monitor the disappearance of greens. That is the trees, the grasses, which is as a result of the excavation processes and the construction of either high-rise buildings or so. Now, when you have that as one of the parameters, remember we started from, you have your parameters, you then deploy your tools and sensors. You have that as one parameter. Then the other parameter is the heat waves that you get as a result of the presence of human beings. That will give you the red area. I'm using this as an example. So in your sensor will have to the component of your sensor will have to bring in, one, the sensing of the green areas. Two, the sensing of radiations or emissions from body heat as a result of the presence of human beings within that environment as per that time. Because when you do that satellite based monitoring, you will discover that at particular times of the day, periods of the day, the heat emissions from human beings will either be higher or lower, indicating presence or absence. I don't know if you are with me.
I'm with you,
Hello,
sir.
Adoga. Okay, good.
Yes,
Now,
sir,
the other one,
100%.
then the other third parameter that you must consider is that of particulate matter. That is the dust, the quality of air, the particulate matter that is found since you have identified that construction is rapidly going on. Definitely, there will be the presence of particulate matter. You then check, you have a sensor that will definitely identify particulate matter, particularly when they are above the 2.5 parameter, that's standard parameter. So your sensor, which will be built into your satellite-based imagery, will have to be able to monitor these two. And using the Internet of Things, these things are things that send in signals into your control room or your cloud. The other thing you need to also do is, where necessary, the ozone depletion rate. But that is going deeper than is necessary. For a place like Abuja, you don't need to do that. These three parameters should be able to tell you the movement and the presence of humans and activities around Abuja metropolitan area. I don't know if that answers to your concern.
Yes, sir. It's okay, sir. Thank you.
It's okay. You're welcome. Any other concern before we round up this class, this morning section?
Yes, sir. Good morning, sir.
Okay. Tell us, how are you?
I'm fine, sir.
Okay.
I so much enjoy your lectures.
You're welcome, sir.
I have a particular question. You
Okay, go
spoke
ahead.
about all the monitoring methods on soil, air, water, biodiversity, and all that.
Yes.
We can see around us. But I want to draw our attention to something that we cannot see, but yet we are standing on, the earth core.
All right. Okay.
Well, I'm talking about the earth core.
Okay.
You know, you and I understand that the earth core constantly heat up or cooked up.
Yes.
So which of these monitoring methods can be deployed to dictate the heat in the earth core that is deep below the ground we are living on, that most of the time result to volcanic eruptions and natural disasters in other parts of the world. Sometimes it's even capable of even generating flood and all that. So which of these monitoring methods can be deployed in remediating this kind of effect? Thank you.
All right, thank you very much. For earth core monitoring, there is a deep earth sensor that is used for monitoring them. That's why they can predict volcanic eruptions. You understand? But
yes, sir.
It's just like our course content synopsis does not cover deep earth core. That's why I didn't bring it up. But it is something that is done. That is a deep sensor, a probe actually, that is driven deep into the earth core, and it's used to monitor the heat wave, and that way you will now find out that you can predict the heat as it rises, particularly areas that are prone to earthquake, areas that are prone to landslides, areas that are prone to earth tremors. You understand? We have such sensors, and they have substations where they work. These things are done by the people who call seismologists.
Okay.
They are done by people who call seismologists. Seismologists.
Yes, sir.
Are you with me? These
Yes, sir.
seismologists use what they call a nuclear monitoring system. You get it?
I get it, sir.
The nuclear monitoring system, and it's somehow deep inside, some very deep distances down. The distances are up to 2,442 kilometers diameter sphere. You understand?
Okay.
And here, that is how deep it. You can imagine 2,442. So these seismologists have these materials, equipment positioned using the nuclear monitoring system and the magnetic Earth magnetic field to monitor these systems.
Okay.
They even consider the flow of lava. They go to the extent of considering the flow of lava, depend on the heat. Because lava at a particular temperature becomes more fluid or less fluid, as the case may be. So they can predict whether it is boiling hot enough to erupt or not.
Okay.
So it is possible, and it is done using that nuclear monitoring equipment. But just because it is not part of our this thing, that's why it was not brought up. But does it exist? Yes. You understand?
Okay.
It exists, and they have sources of where they do that.
I get you, sir. So,
Okay.
is it possible? That brings me to the second phase of my question.
Okay.
I'm clear on that. You talked about using thermal sensors drilled into the earth core to monitor thermal activities and all that. So, is it possible to integrate that the satellite and the thermal sensor interface?
Yes, we can. You see, when you are able to identify a particular heat sink, let's use the word heat sink. You understand?
Yes, sir.
You can do a mapping of the area using a satellite imagery. Remember that the sensor you drop inside, this thing can get up to 4,300 miles. So it's really deep down.
Yes,
you
sir.
can now have this thing coming up and being picked by the satellite imagery, and you can map out the area where the possible either earthquake or landslide can take place. You know, the landslide, what we call landslide, is the tectonic shift, the tectonic plate shift of the earth. And it can happen because of certain reasons. One, the temperature, rapid temperature cooling. It can also happen because the temperature down there is so hot that there is the cracking and then the pouring out of the volcanic lava. So once that happens, the earth, in its ability to go back to natural state, slides, and they slide above each other. They are on slides, plates. They slide above each other. And when that thing moves, no matter how small, it could be 1 or 2 inches, you see the earth trembling.
Yes, tectonic plates
So that's
movement.
what really, that's what really happens. So it's not every time that you see it as earthquake. No, that could be that tectonic slide or movement which causes the trembling. You see cracks, third rows that are rigid, cracking, railways that are rigid, sliding and shifting. It can be that strong. It happens, and it can be very strong like that. So there is a seismological sensing that happens, and it can be also interfaced with the satellite imagery to show the area where it is happening.
It's okay, sir. Thank you so much.
You're welcome. You're welcome. So I think we have spent our time. I think we have covered what we didn't start with. This is 11:21, and we're supposed to have stopped by 11 o'clock. So I thank all of us who are still here. We are still 98 right now. 98 right now. And I want to advise that we'll have a class rep. And if it is possible, please find out from the authorities if it's possible for you to create, if it's allowed for you to create a WhatsApp group so I can drop these slides there. I can't drop the slides on the general platform, which is comprising of other courses. You understand? Are we there?
Yes, sir.
Yes, sir. We have
Do
a
you have
group.
a class rep? Do you have a class
We
rep?
have a
Hello,
WhatsApp
sir.
group.
Do you have a WhatsApp group? Okay, you can add me
Hello,
to that
sir.
WhatsApp group. I'm not on that WhatsApp group.
Yes,
Okay, sir.
Ongu, I advocate for Onguangus to.
Please
Sir,
add me
we
to
have
the
a
WhatsApp group.
departmental.
If I were to be on that WhatsApp, I would have dropped your slides earlier before now.
All right,
We
sir.
have a departmental platform.
No, I know about departmental platform. What about
We have
ENS
a separate
827?
group. We have a separate group
I want
that.
it on ENS 827, 25-26 section, so that I can
Okay,
drop
sir.
your slides.
Yes. Yes, the person answering the slide right now can do the work.
Okay, fine. So once I am added to that platform, I will drop your slides before your lecture starts so that we can go through it as a discussion. So on
Please
that
let
note,
them
I would.
some of us there. Some of us
Sorry?
are not there yet. Sorry, sir. Some of us are
Everybody
not
should
on that
migrate.
platform yet.
You will be added there. You will be added there.
Everybody should migrate to that platform. And on that note, I would wish you a pleasant day ahead, and as we look forward to our next meeting later today. Thank you and have a wonderful day.
Thank you, sir.
Thank you, sir.
Thank you.
You're welcome. You're welcome.
Please, the class
Thank you, sir.
capacity
welcome.
to be expanded, please.
I think the last time the person sent the link to the group, it was deleted. So I don't know. Maybe you forward your number to him and then he'll add you. I've
We
not
have another
forgotten it.
WhatsApp group now that is managed by Ben Luke Yobun. So he can equally connect to the lecture. It's all right.
And I was the one that. So when I sent the link, they deleted it. So I contacted Joy to know, and she said I didn't send the link.
Please, who is adding on that group?
I am admin, sir.
You can add me.
All right, I'll do that, sir.
Okay. Thank you.
You
Do you have
can
my
also
number?
add me, please.
I will do that, ma'am.
Send the link so that some of us. Do you have my number?
Yes, let me drop my number on the chat here.
Please just add me.
Good morning, everyone. I think what the lecturer is trying to say is, do we have a dedicated WhatsApp platform for his course, just his course alone, not our general student platform?
Not general WhatsApp group.
Maybe we'll create another WhatsApp group for just his course.
Yes, let's create another WhatsApp platform for just this course we finished, ENS 827.
Exactly. That would be better so that our assignments will not be scattered.
Yes.
Please, suggestion, please. Me, I'm thinking whether we just create a group and link the lecturer each course. We'll link the lecturer so that.
That is why I said the group, the MSC group that guy created, we can just add the lecturer there and then he'll drop
Yes. I think that
slides
would.
in the group. I think that one is better instead of creating different groups.
Yes.
That's what.
But what the lecturer mean is a different group.
It will even make somebody get confused, creating different groups.
I'm not understanding. I think what the lecturer said.
We have already.
But throughout this week, I guess that's the only course we'll be offering. So definitely we can still use the WhatsApp group we have.
Yes.
No, that is not what he said. He said create a WhatsApp group with ENS 827 where we can
exactly. That's the group he said. A WhatsApp group for his own course.
Yes.
So are we going to create a WhatsApp group for it?
We cannot have a
That's
WhatsApp
why
group for
I'm
every
saying
course. That is
we
not the
cannot create
problem.
We
WhatsApp
cannot have
group
a
for
WhatsApp
each
group for
course
each course
now.
How
now.
can every course have a
We
WhatsApp
have
group?
one WhatsApp group currently, MSC students
And that is
alone.
fine. We are
So
going
we
with
will
that.
add
Every
him to add
We
ENS
are
to
going
student
with
add
will
that
those
do
one.
it.
There
lines.
is no multi for WhatsApp. Already we had one that is functional. So let us all go into that one and continue our activities rather than creating.
There are no lecturers in that WhatsApp group.
We have a departmental WhatsApp group, so you should go with on that
And that is
departmental.
fine.
Creating WhatsApp group in all the courses now, that would be too much. We have about how many WhatsApp? The one for the MSc is okay.
So we
All the
can be
courses.
creating each course now. We have to create WhatsApp group on it. Why is that?
Sorry, please. When I created the group and I dropped the link on our departmental group, and I later spoke with Mrs. Joy to say yes, we can have our separate class group. Though a discussion was ongoing, and I dropped the link not at an appropriate time. So in the class.
Good morning. I have dropped the WhatsApp link in the chat comment in the chat. I think every other person can see the link to the WhatsApp group on the chat. So you could just click on the link and it takes you directly to the WhatsApp group. So click
Please,
on the
the
link.
group capacity should be expanded.
Yeah, that is being worked on by the technical team of IFS. They are working on it.
Whether you want the lecturers in ESS.
The group link, it's in the chat. Just look into the chat and
student chat.
Okay, sorry, Mr. I also added Mr. Ongo as an admin. I'll add Mr. Ongo as an admin of that group, and the link will be dropped so that we can all.
It has been dropped, sir. It has been dropped.
Okay.
Check the chat. Check the chat.
Admin, please approve the
I am
request.
dropping. The link has been dropped again. Check the chat. Check the chat. It has been dropped again.
Admin, please approve the request.
Which
Yes,
of the
I'm doing that.
I clicked on that link and it's pending, showing me pending.
Just hold on. It's pending. The admin will add you. Just hold on.
You will just do one place. They laugh. We they hear you. So you go do one place. They laugh.
So the link is in the chat group now.
Contribute.
The chat.
Well, actually waiting for the person to
link and
accept
join.
us.
Have we all seen the link?
Yep.
Yeah,
yes,
to
sir.
me, I've seen that.
For
and I've also requested to join. So I'm waiting for acceptance.
Please, you will be accepted.
Thank you, sir.
Who is our course rep now?
Persons that are using, please, those I see Oppo, there is an Oppo, there is a EVPRO.
There is Infinix, something.
Yeah, there is Infinix somewhere. Please reconfigure your system to carry your name. As we are aware, this call is being recorded. For attendance purposes, I can see Samsung SM something. That's a Techno BG6i. Please find a way. Go to your Zoom. Use your name to configure your Zoom instead of your number. EIV, PRO, we work on yours. Yes, in Phoenix, please. We work on it. Thank you very much. I guess we've all seen the link to the WhatsApp group.
My number, renaming.
All right, thank you very much.
Like the one I got here, this age, because my complaint, but I can.
We'll converge later.
Okay.